Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics, and welcome to the last lecture of this particular series, that to the kind of concept called as survival analysis. It is a part of actually count data modeling, and in fact we have already discussed the concept of count data and discrete data, and we have discussed two typical models relating to count data modeling, that to the concept of Poisson regression modeling and the concept of negative binomial regression modeling. And we have already highlighted various requirements and the structure through which you can pick up a particular models as per the particular requirement and the kind of with respect to data structure, and again that to whether it is a Poisson regression modeling or negative binomial regression modeling. In response to Poisson regression modeling and negative binomial regression modeling, we like to analyze a case which is called as survival analysis, which is actually part of this count data modeling. And then we like to discuss what is this particular concept and how we can actually bring this situation and that to connect with Poisson regression modeling and negative binomial regression modeling. So, here the overview of this particular lecture is like this. So, first of all we like to understand what is survival analysis and what are the kind of data, and that means of course, since we are discussing count data modeling and discrete data modeling, the choice of the particular model exclusively depends upon data structure and the features of the data. So, that means first hand we have to understand whether the data is actually count data type, that to non-negativity integers type, and again we like to check actually whether mean and variance are equal or mean and variance are unequal. That is the first two checkpoints through which the entire count data modeling will be applied. Then we bring a kind of concept called as survival functions, and which we call as hazard functions, and then we will touch upon parametric versus semi parametric regression technique, which will be also under the count data modeling. Usually survival theoretically you understand what is actually the concept survival. So, that is how we have already discussed the typical models count data models are exclusively used in a kind of situation like death, incidents, kind of health issue. So, means typically where the concept of survival is very much meaningful, right. So, basically death occurrence or accidents occurrence, these are the situations where this kind of modeling is very frequent, and we can deploy such kind of models in these areas. That is why we are discussing this particular analysis. So, the usual trend of this survival analysis will be like this, it is actually over the time it is actually declining, and roughly the question is what shape is this functions, right, and again what was a person's chance of surviving first 20 years, first 36 years. That is what the prediction is about, because somehow it is connected with life cycle hypothesis, and this is survival analysis. We are trying to estimate this curve, only the outcome can be any binary event, not just death. That is what the beginning of this survival analysis and the kind of game. So, it is kind of yes no whether death occurs or death not occurs. That is how the. So, that means this particular analysis or this particular modeling is again a special case of count data modeling, okay, where means we have started with count data modeling with two requirements, that to non-negativity and integer types. Again it may be 0 1, that is the binary structure, or it may be something different than from the 0 1, but 0 1 type of like integer programming. So, we have a 0 1 kind of statistical modeling or econometric modeling, which we typically called as survival, one way called as survival analysis, and another way we have already discussed in a nonlinear framework, that's called as binary choice model. So let us see how is that survival analysis structure. So first of all, what is exactly the survival analysis concept? So basically statistical methods, it is the method for analyzing the count data on the occurrence of events, and what I have already highlighted, the events here it can be actually include death, injury, accidents, one kind of illness and recovery from illness. That means basically it is a binary type of situation, but most crucial kind of touch point is the question of survival. So survival means yes, yes or no, seriously injured, not injured, accident happened, not happened, one set of illness, no, yes, no type of things. So then data will be actually from the randomized kind of situation, and then the study can be actually applied, and then you can analyze as per the requirement. So let us bring some kind of example, typical examples where the what should be the target population and the kind of sampling. So here you see here disease free at risk situations where we have two different divisions, interventions and control, again disease and disease free. So again in the control, disease and disease free, that means actually we need to bring a path diagram such a way so that this model can be applied as per the particular requirement. Again, so the randomized assignment is actually with two divisions, of course population related to patient, and then treatment and control. So with treatments, so we have two division, cured, not cured, then again with control, cured and not cured. So that is how, so that means exclusively depends the kind of count data, and that too you have to develop a structure such that this kind of model can be applied. Again treatment control, so died, the division will be dead and alive, and again dead and alive. So that's how yes no type of situations, right. Again the two divisions will be exposed, unexposed, and again disease and disease free. In case of unexposed, free and disease, and then disease free. So this is how the kind of case, and we are bringing such kind of environment here. So this is a kind of plotting with respect to Women's Health Initiative data. So we will find how this kind of distribution is happening. So it's actually kind of two different kind of situation, and again the cumulative incidence. Similarly, a low fat diet data. So we have actually comparative kind of situation, that too with respect to low fat diet and then control. So that means we need actually two different situation through which actually you can enter to this game and analyze the situation. The basic objective of survival analysis is to estimate time to event for a group of individuals, and such that the time second heart attack for a group of patients, to compare time to event between two or more groups, and then finally to assess the relationship of covariates of time to event, right. That the checkpoint, and the expected time to event is 1 by incident rate. That's how actually basically this is a very useful, and we can say that it's a kind of problem relating to health analytics. And in the health analytics, this is one of the biggest kind of component through which actually you frequently use lots of count data modeling, that to the game of survival analysis. Why not the issue is why not compare mean time to event between your groups using actually t-test or linear regression. That's how ignores censoring concept. And that means actually before you start structure, we have to actually bring the such kind of checkpoint, and then think about the particular structure, and then deploy this model. So two things are very important here, time to event and then censoring. Time to event means time from entry into a study until a subject has a particular outcome, and censoring is a subjects are set to be censored if they are lost to follow means loss to follow-up or drop out of the study, or if the study ends before they die or have an outcome of interest, and they are counted as alive or disease free for the time they were enrolled in the study. So, that means it is actually sometimes this kind of problem is a continuous problem and experimental type, and so we do continuously monitoring, then we use this data for this kind of modeling. So, that is why this is very useful for health management and health care. And two immediate issue is actually time variable and censoring variable. So, time variable which is called as Ti, and then censoring variable which is called as Ci. That is how the structure is here. So, a time at least disease free observations or time at event, and Ci equal to 1 if had the event, or Ci equal to 0 not event. That means actually it is a kind of dummy kind of structure, and that too the structure is a binary structure altogether. So, it is what I am saying that it is again specialized case under the count data modeling, and then we like to discuss the situation. So, right censoring, and that two common examples is termination of the study, death due to a cause that is not event of interest, loss to follow-up, and then again we know that the subjects survive at least to time t. So, one instance is it t greater than to small t, and Ti the event time for an individual is a random variable having probability distribution, and second, different models for survival data are distinguished by different choice of distributions for Ti. So, that is how the game. So, so far as a describe means a survival distribution is a concern. So, we have actually parametric survival analysis, and is based on so called waiting time, that is waiting line distribution, and exclusively it is a kind of exponential type of probability distribution. And the idea is that assume that the time to event for individual in our data set follow a continuous probability distribution, and if not, then it will follow the different kind of distribution. Of course, the dealing is actually with respect to either Poisson regression modeling and negative binomial regression modeling, but subject to condition is that the kind of survival structure will be bring into the picture. So, here is actually the kind of probability density functions. In the case of human longevity, so we like to check actually Ti is unlikely to follow a normal distribution, because the probability of the death is not actually highest in the middle age, but at the beginning and at the end of life. So, this is actually hypothetical examples, but we can means typically it is a question of life cycle hypothesis. So, one of the most important actually component in the survival analysis is the density function, and like Poisson regression modeling and negative binomial regression modeling, because it is actually special kind of problem relating to count data modeling. That means it is a conditional kind of problems, since we are putting actually 0 1 in the count data. So, that by default it is a conditional problem, and it is more specialized and slightly different, and maybe little bit different, because the data will be experimental type, and you may not so easily you can have this kind of structure. So, the function will be with respect to limit delta t equal to 0, and the probability of t less than 2 capital T and less than 2 t delta t divided by delta t. That is how the move we have to create a that means the data structure or data transformation or data restructuring will be follow with respect to this function, so far as survival analysis is concerned. And then the density function, cumulative density function will be St equal to 1 minus p t less than equal to t. That is what we call as 1 minus f t. So, somehow it is actually connected to normal density functions, and then you see here the cumulative survival in situations where we have a survival functions, and the hypothetical data will be like you are plotting with respect to cumulative distribution rather than simple density. This is another kind of examples, and this is what actually called as hazard functions. And hazard rate is actually is a kind of incidents what is happening, and with respect to age, how is the kind of occurrence that you have to first predict. That means technically as usual we have to go for plotting and check what is exactly happening. And in the corresponding to whatever we have discussed, the hazard functions, instead of ST we can call it HT. So, same structures, and the probability that if you survive to T, you will be having a kind of event, and then hazard function density and survival rate equal to HT equal to FT divided by ST, and then then we can apply actually some kind of Bayes theorem or Bayes rules to give such kind of scenario, because it is a conditional problem altogether. So, so far as a conditional probability is concerned, and Bayes theorem is the solid theorem which you can bring and connect, and then we can discuss some way to analyze the situation. So, the density is actually into the pictures, and with respect to probability density function, that to this kind of conditional situations we have to bring such environment so that we can apply the kind of models. Means the question is actually if you are using actually when this kind of models. So, now how is the approximation to the normal distributions, which is actually considered to be a well known distribution so far as the entire econometric analysis or statistical analysis is concerned. What I have already mentioned that when n tends to infinite, and most of the distributions will be follow the normal distributions, and then we have already discussed the case where the exponential distributions or the kind of Poisson distribution, negative binomial distribution can close each others when n tends to infinity. The similar situation will be also here. So, that means every time two things very important. So, that means if you increase the sample size indefinitely and take care of the outlier issue, then most of the distributions will follow normal patterns and behave normally, and then you can predict the particular problems and the particular requirement very easily as per the particular engineering requirement. So, the common two functions are exponential type, and which is actually means where the hazard is a constant over time, that is the simple one, and the other one is actually hazard function is increasing or decreasing over times. That is like exactly the kind of Poisson structure and the negative binomial structure. One case there is no question of over dispersions, in another case there is a kind of over dispersions. So, the hazard function S t equal to h, and exponential density function will be h e to the power minus h t. That same things we have to bring again, then you have to structure the model. And so far as a survival analysis is concerned, we have couple of items which you like to understand and then connect as per the particular requirement. So, first thing actually to understand the hazard and hazard rate, and then hazard from the density and survival from the density, and then density from survival f t, and again density from hazard. So, that means typically these are all somewhat we can call as different mathematics or mathematical modeling you are supposed to work out and know before you start doing the modeling, and that to do this kind of count data modeling. So, without knowing these ones you cannot actually do this analysis. That means actually what is more important here, since it is a specialized type of problems. So, of course, data will be like that, and you need a restructuring of the data, and you have to somehow bring such a kind of situation, so that this particular model can be applied to analyze the situation. Sometimes outliers may create a problems, because when the outliers will be there in the system, there is a high chance over dispersion, and where mean and variance may not equal. But by the way, with data transformation, increasing sample size and restructuring of data, and somehow if we can remove the outlier, then the problem can be solved. So, now corresponding to this structure here requirement. So, we have sample examples. So, we have to bring ST, then somehow some kind of restructuring, then finally you have to find out the hazard rate and the its model. This is another kind of example, and corresponding to the hazard type of solutions. So, which actually is somehow connected to parametric versus non-parametric regression techniques. In the parametric versions, the two parametric multivariate regression techniques. So, model the underlying hazard or survival functions, assume that the dependent variable, that to what time to event takes on some non-distribution, whether it is actually a exponential type or log normal type. So, that means actually it is the game between what we can call as dependent variables. So, that means the entire count data modeling specifically actually what I can call as dummy type of situation where the specific target is actually to dependent variable. So, that means all the restriction will go to the dependent variables, like what we have already discussed, the concept called as dummy dependent modeling. So, here actually we have no issue about the independent variables, but we have issue about the dependent variable. Like we have already discussed 3 different types of models in the case of dummy dependent modeling, that too starting with linear probability model, logit model and probit model, and more or less the same similar structure or same structure we are bringing here in the case of count data. The only difference is that in the case of dummy dependent modeling, so we have no strict guidelines about the on data where we can use actually scaling data. So, the relativity will be allowed there. For instance, the degree of difference, like good, bad, best, like that kind of situation. But here the specific restriction is that we need actually some kind of numeric kind of structuring where fractional values will not be allowed, and the information should be integer type, and that too sometimes it may be 0 1 type, sometimes different, but ultimately it should be integer type. So, that is how it is a kind of specialized kind of situation where you have to apply and then connect the model, means particular model as per the particular data structure and the problem requirement and the kind of engineering requirement. So, the third point actually estimates parameter of these distributions and corresponding to baseline hazard function, and like what we have already discussed here, these are all various parameters related to hazard functions, and these are the entire these are all mathematical modeling related to survival analysis and then hazard type of modeling. And with the sample examples we have highlighted already 2 cases. So, one of the important things is to estimate these parameters and then connect with the regression modeling, where the the subsequent objective is to study the impact of independent variables to dependent variables. That means actually here we have a little bit complex and 2 types of requirement, that to specification about the dependent variable, how you have to bring the dependent variable in a kind of structure where we can apply the survival analysis or hazard type, bringing the hazard type of situation without any restriction to the independent variable. But whatever the restriction and the family structural requirement, you have to do and then restructure the data as per the requirement of a particular modeling. And then last but not the least, estimate covariate adjusted hazard ratio, which is actually ratio of hazard rates. So, likewise this is what actually parametric regression modeling, and we start with simply what I have mentioned, log HT equal to mu plus beta 1 x 1 beta 2 x 2. Of course, I represent the different kind of sample structuring, looks like baseline model. Similarly, if you restructure little bit, then you will find different kind of modeling structure altogether. So, that means technically these are all not different corresponding to the models which we have discussed earlier. This is a similar kind of models, but only important thing is here the type of data, the structure of the data, and the typical problem which you can actually apply. So, that means this kind of models mostly apply to transportation kind of problems and medical science problems, where this kind of incidents are very frequent. Of course, these problems are very rare, but still the frequency is very high in these areas, and depending upon a particular problem and the kind of requirement, whether it is a organizational requirement or the kind of country requirement or situation requirement, you can just pick up the problems and arrange the data, or you can generate the data on a experimental basis depending upon the requirement of a particular model. Then you analyze the situation as per the requirement. So, that means technically, so there are various ways you can actually analyze. So, this is how another way of bringing this kind of hazard functions. And there is again corresponding to these clusters, there is a concept called as Cox regression. It is slightly in this basket which is called as semi parametric, and Cox models the effect of predictors and covariates on the hazard rate, but leaves the baseline hazard rate unspecified. It is also called as proportional hazard regressions, and here we we do not actually assume knowledge of absolute risks, and then finally estimates relative rather than absolute risks. That is what the kind of structure. This is how the components of Cox regression modeling, and it is more or less similar kind of survival analysis, and not so much different, and hazard functions should be actually exclusively, which is called as HR proportional hazards, and the point is to compare the hazard rates of individual who have actually different covariates. So, this is another kind of instance, and then last but not the least, actually we start with the parametric, then semi parametric, and then the kind of non-parametric, and I am not going in details about all these classification again. So, non-parametric estimation of the survival function is like that no mathematical assumptions either about the underlying hazard functions or about proportional hazards, and it is simply brings the situation where the empirical probability of surviving past certain times in the samples, taking into account called as censoring samples. That is how the kind of situation, and ultimately the requirement is that we have discussed various types of models relating to the some of the engineering problems relating to data, and then various kind of situations and the kind of requirement. Ultimately, I am bringing to the actually the entire structure about this engineering econometrics before I conclude this particular sessions and this the conclude this particular lecture series. So, I like to once again bring the abstract of this particular course. So, starting with introduction to engineering econometrics, then we have discussed the concept about the exploring data. So, that means data is one of the biggest component which you are in the process of solving engineering problems, and that to do the modeling, which we have actually highlighted in a kind of special category in the last lecture, that to count data modeling. But whether it is a count data modeling or any kind of modeling like dummy modeling or time series modeling, penal data modeling. So, data is actually big deal every times. So, until unless you know the data structure and the behavior of the data or the kind of structure of the data, you may not actually do better modeling, and if you could not do better modeling, you cannot actually solve the engineering problems as per the particular requirement. Sometimes having the data, you visualize it to know what type of function you can apply, then go for the estimation and the kind of process through which you can analyze the problem. Then we have already discussed various descriptive econometrics as per the engineering econometrics requirement and problems requirement, And then we have discussed various types of models. In one hand, we have classified into two different structures, linear regression modeling and nonlinear regression modeling. Under linear regression modeling, we have discussed various types of models, starting with the simple one, the bivariate one, and that is the bivariate one, and the multivariate one, and various special cases, and the diagnostic tests, then the specification test, goodness fit test, all these kind of reliabilities we have discussed. And same thing we apply to the nonlinear regression modeling, whether it is a type of functional forms or the kind of as per the data requirement or something like that. But we have discussed various types of nonlinear regression modeling. Then we have discussed various models relating to time series data, and as a result we bring the situation of situation called time series modeling, where we have discussed various models relating to some of the engineering problems. That means where the time series data can help to solve some of the engineering problems, starting with autoregressive models, moving average models, ARMA models. Then we have discussed various types of volatility modeling. Then again we have discussed various types of VAR modeling, starting with all these time series requirements, unit root co-iterations, Granger causality. So these are the concepts which we have actually highlighted, and these are also requirement of some of the engineering problems as per the need and the requirements. And then we have discussed something called as penal data modeling, just connecting cross sectional modeling, whether it's a linear structure or non-linear structure, and then time series modeling. So it is a concept of where data is actually the kind of big deal. We are just clubbing time series data with the cross sectional data and bringing the situation as per the particular requirement. Under this umbrella, we have discussed three types of models: fixed effect models, random effect model, and generalized methods of moments. And again, in the last unit, we have discussed the concept called as count data modeling, and including the duration modeling. So in the count data modeling, it is somewhat not different, but it is under the umbrella of all these cross sectional modeling, time series modeling, and penal data modeling. And again, under the umbrella of both linear and nonlinear modeling, what is more important in this unit is the type of data, which is actually a special kind of structures, and again it is applied under a special kind of problems, for example like survival analysis. So here the problems relating to this models count data modeling is the data structure, where data will be non-negativity in natures and integer type. And again, so we have a special kind of problems in this count data is called as survival analysis, that to just like 0-1 integer programming. So all in if you summarize, we have covered almost all pool of various engineering econometrics tools to solve some of the engineering problems as per the particular requirement, and whether it is organizational requirement, corporate requirement, or country requirement. But we have highlighted various models depending upon the situation, depending upon the data structure, depending upon the problem environment. And now my suggestion is that you go through all these models, and then depending upon your area of specialization, you pick up the problem, because until unless you understand the problem, you cannot actually pick up any model to solve that problem. So understanding problems is one aspect, and picking up the problem and understanding the problem in another aspect. But this kind of paper or this kind of modeling requires both sets of knowledge, theoretical knowledge, and then the kind of econometrics knowledge. So once you are familiar with all these items, then you can come with situation, and where you can apply these models to solve the engineering problems as per the particular requirement. But there is no such restriction whether to apply only in kind of civil engineering, or kind of health science, or some kind of other engineering problems. It can be applied to any engineering problems subject to the problem requirement and whether the model can be fitted there. If your problem is identified well, data is available. So, just you check the problem and connect a particular model and then analyze as per the particular requirement. With this we will stop here, and thank you very much for choosing this subject, and I hope you have enjoyed all these lectures. And if you have any doubt or any kind of clarifications and how to do practice and how to connect with application, you can keep touch with me, and my mobile and my emails are always with you. So, hope to see you soon again by applying these models in a kind of real life situation and real life requirement. With this wish you all the best to all of you. Thank you very much and have a nice day.